everyone, welcome to section 6.3. So in this section we're continuing with the factoring process, but we're learning about special products. So all the factoring techniques you learned so far still apply, meaning factoring out the greatest common factor first, and then splitting things up into two parentheses if you can. All right, either by trial and error or with the AC method. But now we're looking for some patterns, recognizing some patterns. So recognizing patterns makes the process quicker. It's not necessary, but it's convenient to recognize certain patterns that will save you a bit of work. Okay, so the patterns we're looking for, one is the perfect square trinomial. So what we're looking for here is trinomials of this kind. So you have the first and the last are perfect squares, and they can be for perfect squares with numbers and variables. And the middle one is twice a times b. So it's twice like the square root of the first and the last. Okay. And if that's the case, then this factors into two identical parentheses, a plus b times a plus b, which, because there's two of the same, you write it as square. All right, and you'll see perfect square patterns. If there's a plus for the middle term here, then it will be a plus b. If there's a minus for the middle term here, you'll see a minus b. All right, so here's an example. Let's say I have 4x squared minus 6x. So wait, I'm trying to make one up. 4x squared plus 9, 6x. There you go. Yeah, 4x squared minus 6x plus 9. All right, so basically we can factor this by trial and error, right? But if you notice that this is a perfect square, so 4x squared is a perfect square because 4 is 2 squared, x is x squared, and this is also a perfect square, 9 is 3 squared, then it could fit into this pattern. So your first try, right, you don't have to do it with the AC method. Your first try is to split it evenly. Okay, so 4x squared is 2x times 2x, and 9 is 3 times 3. Alright? Now if, see, I got this wrong. This should have been 12. Okay, I'm trying to do a perfect square thing. Okay, so let me change it. So now if this middle number here is 2 times these, then it's the perfect square pattern and you end up with the same thing. So this is like 3x, 2x minus 3 and 2x minus 3. And this works out because negative 6x minus 6x, you have two identical things that add up to the negative 12x. Right? So then you're going to write the solution as 2x minus 3 squared. Right? So really it's not a new technique. You're using what you were using before, but you're kind of looking for, if there's perfect squares at the beginning and at the end, you want to split things up evenly. Okay, so you can do trial and error method really quickly and get your answer without really any steps, just writing things down. Okay, you should always still check that that middle term works out. All right. Now the other pattern is the difference of squares pattern. All right, so you'll see this when factoring binomials. So we have something like a squared minus b squared. So notice the middle term is missing. So if you have a difference of squares, so a perfect square minus a perfect square, then this is going to factor out in conjugates. So you have a and a plus b minus b. So they're almost identical, but they're not identical because one is a sum and one is a difference. So this will always happen if you start with the difference of squares. So a binomial, yeah, where the middle term is missing, so it's not like the typical trinomial like that. things will cancel out, right? So if I multiply this out, you get a squared minus ab plus ab minus b squared. So these will always cancel out because they're the same values but opposites, one with the plus, one with the minus. All right, so these are the kinds of problems that you'll see in this section.